Hello, you see my lens? It's a lot bigger than the one that's in my eyeball. So you're going to see there's a lot of things with lenses that are very, very similar to mirrors, but a little reversed. So this is convex on both sides, curved outward. You can see the rays of light coming in and they refract. That's what causes it. Refraction causes lenses to work. It's not a perfect one, but you can see it comes together at the focus. So from the center to there is considered focal length. So convex lenses cause converging. I'm going to take and put a skinnier one. I'm just going to literally slide it in place. Now notice how much difference there is in the focal length. The skinnier it is, the farther the focal length. That was almost double. Both of these are curved outward, convex, and they both converge. Okay, that's the focal point. It's going to be very similar to round mirrors where we have a focal length and we have a double focal length. The concave lens causes the refraction to bend away. Now, maybe you can see there's a tiny little reflection over here. That is the focal length at which these originate. So they pass as if they came from a focal length, right about there. All right, lenses, this is concave, and concave causes diverging. All right, let's pop it to the notes. You're definitely going to need a ruler again today. We're going to do drawings, and you need a calculator. All right, so on the first page, not too much information here. So opposite of mirrors, convex lenses are converging, which means a positive focal length. Concave are diverging, which is a negative focal length. So here's the basic picture. Again, we're going to use a principal axis that goes through the center, and the focal length is from the center to F. For concave, same idea, focal length, rays of light, they're going to bend through. Now, one of the cool features of the rays, and it's not in this picture, is that even though we have these focal length ones and we have these rays, any ray of light that goes through the center of the lens will not bend. It will go straight through. It's the lens mirror equation, so let's fix this. We're going to use, probably in our calculator, F to the -1, DO to the -1, DI to the -1. So we're still going to use that. And let's add here that even though we cross multiply, magnification will be an absolute value. Let's just put the absolute value there. So there's no new formula as far as that. All right, let's do some drawings. So we're going to use slightly different rays here. So I've purposely left out the lens because I want you to sketch it in from the information. So in this here, I see that the focal length is -3. That means concave. So I'm going to draw this. And I don't need that on anymore. Draw it in the best you can. It's the center line that we need the most. Okay, this is F. This is 2F. This is F. This is 2F. I don't know if they're drawn to scale. We'll do our best. All right. First ray. Take your ruler. And again, even though technically it bends here and here, we do a kind of an average bend. We take it to the center. So the first ray is going parallel to the principal axis, right to the center of the lens, right to here. And because it is a diverging, remember, it will not come through the focus, it goes away. The line up as if it came from the focus. So take your ruler, match it to where you stopped in the center, and to the center of the focus, and extend it. Now, it's a little easier than mirrors because the second ray literally just goes through the center. Because any ray that goes to the center will go straight, so that way we don't have to bend two of them. So, boom, there we go. Now, are these going to ever meet? No. So we're going to do dotted lines back. This one's already on its own. If I go backwards, I'm already on it, so I don't really have to do that one. So in this one, I'm going to dot it. There we go. It's not a very good dotted line, is it? It's a little more dotted than that. I thought I did a better job. All right, so here's where they cross, right here. All right, so we're going to add 1, 2, 3. First of all, this is definitely smaller than that. It is upright, which in itself means it's virtual. In other words, you could see it in the lens, but you would not be able to make a picture of it. And the fact that I had to do the dotted line back. All right, let's do math. Okay, so I'm just gonna sketch here. So it's gonna be -3 to the -1 equals 5 to the -1 plus di to the -1. So let's put that in here. Okay, -3, oops, on, clear. -3 to the -1. I'm going to subtract it because it's -5 to the -1 equals, and then -1. So I get we'll go 88 centimeters. Okay, SI over SO, which was 1.5, equals DI, which is now -1.88 over 5. So now let's just cross multiply. Let's throw this in here. So make sure you can see it. All right, so -1.88 times 1.5 equals, and divided by 5, I'm going to get -0.56 centimeters. We can do magnification. I'm just leaving it off because it's literally, you can just divide those. Why is it negative? It's virtual. That all matches. Okay, so there is a concave. Concave lenses will always be smaller, upright, and virtual. They will not vary. All right, let's go to the next one. The focal length is 3. As soon as I see that, I know it's a convex lens. Okay, F, 2F, F, 2F. All right, so this is kind of a shorty one. Remember, we're closer to the lens, which means we're going to make it a magnifying glass. All right, so we're going to go straight in. It's not very far. Now, the light goes through the lens, and this one's going to go right through the focus. We're going to go right through the center of the focus. And the second easy one, which is going to be very, very steep. I'm going to have my ruler on the top of my arrow and in the center of my lens. Now, these are diverging. They're going to go away. They are never going to come back. So we're going to extend these. Make sure you're using a ruler or a straight edge. Dot it. Let me see if I can do better on my dotted lines. Much better. Okay, so it meets right there. All right, 1, 2, 3. This is definitely larger. It is upright, which we always know is virtual. And I also did the dotted lines. Okay, let's figure out some stuff here. So I'm going to have 3 to the -1 equals 1 to the -1 plus di to the -1. All right, calculator time. Let's do this. 3 to the -1 minus 1 to the -1. I know that's sort of silly. And then 1 over that answer. So we're looking at -1.5 centimeters. And then SI over SO, which was 1.5, equals DI, which is now -1.5, and over 1. Well, that's easy because I'm just going to multiply these. So I'm going to get, so 1.5 times -1.5 is -2.25 centimeters. And that is definitely bigger, which is what we said. Okay, let's do the last one. The focal length is 3, so it is also a convex lens. F, 2F, F, 2F. All right, so let's do our drawings first. So, and again, I always try to do this above the principal axis so I'm parallel and I don't go crooked. Okay, we're gonna go straight to the center, down through the focus, which is different than mirrors because they reflect through the focus. They don't go through the mirror. Try to put arrows on here. And then the second one, go straight through the center. And sometimes you have to make them longer to fit what you need if you miss something. So like, makes it hit right here. It hits below the principal axis, which means, let's do the 1, 2, 3 here so you can see it. Well, this is definitely larger. You can put bigger if you'd rather. It is inverted, and the rays of light actually cross, which means you could project this image and it is real. Let's do the math. So we have, well, we'll do it down here. 3 to the negative 1 equals 4 to the negative 1 plus di to the minus 1. 3 to the minus 1 minus 4 to the minus 1 equals, and 1 over again. So di is going to be 12 centimeters. Okay, si over so, which was 1.5, equals di, which is now 12 over 4. So let's just cross multiply. So 12 times 1.5 and then divided by 4, we get 4.5 centimeters, which is definitely bigger than the original. Again, this is not going to be all perfectly to scale, but it'll be in the gist. Similar formulas. You're going to do 6 of these. You're going to have to draw in the mirror, the lens, but you will also have to use the numbers to figure all this out and actually place the arrow in the right spot. All right, good luck.